In the previous video, we have discussed the first three problems of Google Codejam 2020 qualification round, and all my solutions are present in my GitHub repository. Link is in the description below. Now it's time for us to move on to the problem D, and I absolutely loved solving this problem. My name is Rachit, guys, and let's start with this video. Alright, so the problem D is a bit long and the description is right over here. I will just skip over that and explain you in easy format what the problem asks. Now before we start with this video, I really love this problem and I really feel that my implementation was totally different and my idea is totally different than what the editorial for this problem looks like, as well as on the left hand side you can see the solution of world rank 1. It's pretty complex, pretty big, and on the right side you can see my solution. It's very small and my idea is also very different or unique, I would say, and this is why I'm very happy to discuss this problem. I absolutely love solving this. So if I can make you understand this, I really would give myself a pat on the back, because I think my teaching skills really have improved then, like seriously. And now I will just start with the video. I will explain what the problem asks. So we have an array, okay, and the length of that array is 100. Okay, it's fixed. I'm calling it length b as 100. Each element of array is either 0 or 1. We have to guess this array by asking at most 150 questions. So this array that you are seeing 0, 1, 0, 0, so and on, the length is 100, each element of array is 0 or 1, and we have to guess it. We don't know originally what the array is. We can only ask questions. So what are these questions you will ask? Now the questions are something like, what is the ith bit? So if you will ask me what is the third bit, I will say okay, the third bit is 0, and I will respond back with 0. If you will ask me what is the ninth bit, I will go and check and I will return to you, yes, this is the ninth bit, which is 1 in this case. So you can ask me such questions and you have to identify the complete array. Now it looks like in 100 questions we can find all 100 bits. We can find all 100 elements. So why do we have the limit of 150 questions then? I mean, I can easily solve this problem in 100, right? So why is there a limit of 150? The thing is, the question is not that straightforward. Here is one more twist. So after every 1st, 11th, 21st, 31st, and so on. So after every such question that you will ask, the original array will be transformed in one of the following ways. So the array can be complemented, which means every 0 can become a 1, or vice versa, or the array can be reversed, or both of the things can happen. Basically it can be complemented first and then reversed, or it can be reversed first and complemented then. Doesn't matter, order doesn't matter, but the thing is both of the operations can also happen. And the fourth choice is nothing will happen to the array. So now the problem is a bit difficult, because as you are asking me, hey, what is the ith bit, I will tell you honestly what is that bit, but when you will ask me the first question, the 11th question, the 21st, the 31st, the 41st, and so on, whenever you ask me the question at this point, my array, original array, would be transformed in one of the following ways that we have discussed. And now you have to give me the latest state of the array in just 150 questions at max. So now it's not that easy, isn't it? Because we don't know, like after every such questions, like after asking the 31st question or 41st question, I don't know what did you do. Have you reversed the array? Have you complemented it? Or maybe you have done both, or maybe nothing. I have no clue. And so we have to print the final state of the array, and the question is, how do we find which operation occurred? Now the best thing about my idea is that I actually don't care about which operation occurred, and that is something which blows my mind away. And now I will let you think. I would really encourage you to take a pause and think, because this is one of the questions which I really feel can come in Google on-site interviews. The difficulty level is fairly same as that which they ask to candidates on their on-site interviews. I have interviewed with Google multiple times, once for Bangalore location, once I also flew down to London. Believe me, I know this is the level which they can ask. So I will give you a few seconds, take a pause, and take pen, paper, and start writing something over it. All right. Now I will just move on with the video, and the first hint that I would like to give you is that you should focus on the pair I, comma b minus 1 minus I. So b is the length of the array, remember? What does I, comma b minus 1 minus I mean? So it essentially is the pair of those elements which will interact with each other when you perform the reversal, right? So in case you perform a reversal on this array, as you can see on both right and left, these are the positions which will get swapped. These are the positions again which will get swapped. So this is what this pair I, comma b minus 1 minus I mean. Another example would be this. All right. So consider such pairs and think how will they change with respect to different operations. So once I did that, I am having this pen and paper diagram that I had drawn. So on the left hand side, you can see that if I take the pair 0, 0, if I complement it, it will become 1, 1, right? If I reverse it, it will stay the same. If I do both of the operations, it will again become 1, 1. And if I don't perform anything, it will stay at 0, 0, right? If you talk about 0, 1, so if these are the bits present in the pair b minus 1 minus I, so 0 and 1 is there, means that if you swap or reverse them, it will become 1, 0, right? If you complement it, it will still become 1, 0. And if you will reverse it, it will become 1, 0. So if you start doing this and build this table for all these inputs like 0, 0, 0, 1, 1, 0, 1, 1, and you build what will be the eventual result for each of the 4 operations which might happen, you will get this table. And now if you will observe this carefully, what I can claim is that if the pair changes from 0, 0 to 1, 1, then all other 0, 0 pairs will change to 1, 1. And all other 1, 1 pairs will change to 0, 0. So this was a very strong observation. If a 0, 0 pair, any such pair changes to 1, 1, then all other 0, 0 pairs will change to 1, 1. And what do we mean by 0, 0 pair? It means that we are considering I, comma b minus 1 minus I, because this is the pair, or this is the pair of those indices which will interact with each other in case reversal happens, right? So if that pair is 0, 0 and it changes to 1, 1 after that, after any of those 4 operations, but if it changes to 1, 1, if any one of them changes to 1, 1, I know that all other 0, 0 pairs are going to change to 1, 1, and all other 1, 1 pairs are going to change to 0, 0. Okay, it's a very powerful statement. If you're not clear with this, go back to that diagram that we had on previous slide and ensure that you are clear with this. Let me expand this a little bit, and now another observation is for the pair of different parity. So if we check the pair 1, 0, and if it changes to 0, 1 after any of the 4 operations, I can claim that all of the rest of 1, 0 pairs in my array are going to change to 0, 1, and all of the 0, 1 pairs are going to change to 1, 0. So all we have to do is check if any 0, 0 pair has changed or if any 1, 0 has changed. Okay, it's not exactly that. Basically, we have to check whether a pair of same parity has changed, and we have to check whether a pair of different parity has changed. By same parity means 0, 0 or 1, 1. By different parity it means 0, 1 or 1, 0. Okay, so what we have to do is, if any 0, 0 or any 1, 1 pair changes, then all of these pairs of same parity are going to change. Similarly, if any pair of different parity changes, all pairs of different parity are going to change. 1, 0 is going to become 0, 1, and 0, 1 is going to become 1, 0. I really don't care which of the 4 operations happened. I just need to know whether a pair of same parity has changed and whether a pair of different parity has changed. If they have, I know that all rest of them are also going to follow that. And now I will start with the implementation. So first what I'm doing is basically I'm iterating on the indices for the first half of the array, and I'm basically assigning j the value of b minus 1 minus I. Now please pay attention. And now what I'm doing is I'm asking what is the present element at I and jth position. So I'm asking, and whatever that returns, I'm storing that in arr I and arr j. Once I have the values of arr I and arr j, I simply compare their values. If they are same, I know that their parity is same. So si is a variable which was initially initialized to -1. But now since I know that this present pair that we are having of I comma j, we know that they are same, so their parity is same. So I'm assigning si to I. I'm storing basically a reference to any pair which is having same parity, both zeros or both ones. And one other thing which I am doing over here is I'm assigning same I and same j to 1. What essentially same I is telling me is that whether this present pair which spans from I and j, is that a pair of same parity or not? Okay, so if same I is 1, I know that I and j are of same parity. If same I is 0, I know that I and j are of different parity. All this is all that I'm doing. And if the arr I and arr j values are different, I'm basically only storing di value to I, because di is storing the reference to that pair or that index at which the pair is of different parity. Once I have that, for every 11th, 21st, 31st, 41st query, I know that I have to modify my array because one of the other 4 operations might have happened. So at that point of time, I really want you to focus on this operation right now. What I am doing is I'm asking 1 or 2 questions, but at the end of 1st, 21st, 31st and so on, all I am doing is I'm updating my array. And how I am doing is I'm taking XOR of every element with some update same k. We will come to that, what is that. So to explain what is going on over here, please pay attention. We know that if bit I is same as bit present at b minus 1 minus I, again b is the size of array. So if both of these pairs are having same values, the parity is same, and that's why same I is 1. We know that. We have seen that just few seconds back. And if that's not the case, we know that the parities are different and same I is 0. So now what I'm doing is, if pair of some parity changes, hear me carefully, if pair of some parity changes, update 1 turns to 1. And if pair of different parity changes, update 0 is set to 1. Okay. So what I'm doing is, if a pair of same parity is changing, if any such pair is changing, I'm updating so basically update or UPD is nothing but an array of 2 elements, and UPD 1 is 1 only when a pair of same parity is changing, and UPD 0 is 1 only if a pair of different parity has changed. So now tell me, for a given I, what is UPD of same I telling me? It's telling me that whether the bit present at ith position needs to be changed or not. It needs a toggling or not. That is exactly what this update same I is telling me. And XOR operation, which is denoted by this hat symbol, is famous for doing that operation. So that is why what I'm doing is I'm iterating on the complete array of size b, and for every kth element I'm taking the XOR with update same k. Now how do we build this? This is what we are doing over here. Update 1 is nothing but we are checking whether whether there is a change in the bit of same parity or not. So that's why I use si over here, right? I'm asking the bit present at si index, and I'm taking the XOR with the current value. So if they have changed, this will result 1, and update 1 is set to 1, and that is why I'm setting this. Similarly, for update 0, I am querying the new value present at di position, and I'm taking its XOR with my current value present at di position, which is represented by arr of di. So I'm taking the XOR with the new value and present value to store or set the correct values for update, which I'm essentially using finally to update my array. So that's it, guys. That's all we have to do over here. And finally, what I'm doing is I'm printing my answer over here. I am having this array which is having 0 and 1, but I finally need to print a string. So that's why I'm converting every integer bit to a string. And that's all I am doing. And I am printing my answer, and I am checking whether the judge is giving me a yes or no on that. That's all I am doing. You will see that I have used some fancy words over here, or fancy functions which I have declared above in my template. So out is a function which I'm using to print to standard out, and I'm using endl which flushes. So this is something which you have to use in interactive problems. I don't want to go much into detail, but yeah, it's a very simple function which is basically writing your variable to standard output. And ask is the function which is basically asking from the judge what is the new value present at given index. So that's all, guys. I hope this was fun. So all we are doing is taking the input, doing the initialization. Whenever we reach the 11th or 21st or 31st query, we are handling the updates to figure out whether a pair of same parity and different parity have changed. If they have changed, we are updating the array accordingly, and we simply continue to ask the rest of the array, and that's what you are exploring here. So I hope this was fun, guys. And problem E, it was very tough. In fact, it needed you. Basically, the people who have solved it, they were familiar with such kind of problems. I have seen in comments on Codeforces that people referred to existing problems on Catis website. I have not used it, but I could see that they were having some Latin square problems, and the people who have actually solved it and were able to complete it in the contest itself were having some prior knowledge about this. So don't be sad if you were not able to solve all the problems. In fact, I was also not able to solve the last problem, and I could see the top 10 fastest solutions on this website, but I could not see the code for that. Also on Codeforces, a lot of red coders had suggested like really, granular details. It was not a very consistent solution, I would say, and there is a lot of debate going on even on Codeforces. So don't be disheartened if you are not able to solve the last problem, but I seriously hope this fourth problem was fun and you really loved watching this. This took me forever to edit and create, so please show some love and support. Please hit the like button, share this, and comment what you want to watch next. I will see you next time, guys. And if you enjoyed watching this, watch the complete Codejam playlist. It's properly structured, and I will put all links in the video description. That's all I had for this video, guys. You can follow me on my social medias. The links are shown in the video, and hit the bell icon if you have not already. And thanks for 100k. Super happy, and I will see you in the next one.